All right, so it's 8 o'clock in New York time, and it should be like 9 a.m. in China, and the morning in different areas, different countries in Asia. Well, I want to first welcome everybody to this workshop. My name is Zi-Kui. I'm a professor at Penn State. I'm going to give a short introduction. Then Richard Otis will introduce the PARC, and Brandon Buckland is going to introduce SBA to you. Let me start share my screen, give a short presentation to kick off the workshop. First, I want to thank Richard and Brandon for organizing this workshop to present the two tools we have been developing in the last several years. One of them called PARC, another one is SBA. So the first question would be, why develop them for CAFAT? I know that many of you are CAFAT practitioners, but I do want to give a one slide about CAFAT.
Dr. Liu, I'm not sure if we're getting the shared screen.
Not shared, just like last time. All right. Let me share now. So I'm going to restart. Okay, I want to welcome everybody to this workshop. I want to thank Richard Otis and Brandon Buckland for organizing this workshop to introduce two tools, open source tools we have been developing. One is PARC, another one is SBA. The question is that why do we develop these two tools for CAFAT? I know that many of you are CAFAT practitioners, but I do want to give one slide about the CAFAT community. It has the annual conference. Unfortunately, we could not have this year due to the COVID pandemic, but we did have every year since 1973. It's a golden conference style. And we also have a foundation. It's called CAFAT Incorporated, private foundation since 1975. So it backs up the annual conference financially, and it gives out scholarships and awards. We also have a CAFAT journal, which was established in 1977. And since 1973, or actually 1970s, we start developing different tools and the databases. Those tools and databases are the backbones of ICME and MGI, Material Genome Foundation initiative. ICME is integrated computational materials engineering. And as you can see that at least a few commercial tools here, SumoCAD, FactorSage, CompuSerm, Pandat, and GMAT Pro, and the MatCAD. So it's available for you to purchase. And also there's some open source codes. One of them is OpenCAFAT, which is very similar to SumoCAD. Thermochemica, that's one developed in Canada. PARC, developed by Richard. And also for the SBA is for CAFAT modeling to develop the databases. And as many of you know that CAFAT modeling is to model the Gibbs energy of individual phases. Usually we have temperature, pressure, composition, but this one is very important. It's called internal degree of freedom. So you can go to metastable states and even go to unstable state. And to do the modeling, you have two sets of data. One of them is the derivatives of Gibbs energy. It's the first derivative and the second derivative. Give us heat capacity, enthalpy, entropy, and activity. Another one is phase equilibrium. Is when the driving force is equal to 0. You get the phase stability and the phase boundary. Take the two sets of data. You develop a database, start from one component to binary, ternary, and the multi-component systems. And then you can use the database to material design. The one, of course, is the equilibrium. They can do driving forces and the physical chemical properties through the first and the second derivatives. And the modeling around 2000, before 2000, year 2000, most of the modeling were done by using experiment data, some estimation. And since that time, a lot of first principle calculations became available. But we know that first principle calculations, some of you were in the workshop yesterday, you find it's mostly 0 Kelvin, but you can also do the finite temperature through statistical mechanics. Now take experiment data and the first principle data with the finite temperature data, then you can have much better modeling and have better predictive power of your database. And in this, I wrote a review paper last month, published. Oh, now it's 2 months now, October. And they need another review, what happened in the last 10 years, or actually more than that. The previous one was in 2009, this is 2020. Summarize the computational thermodynamics, and also more importantly, its applications. So the reason we want to use PARC and the SBA, develop these two tools, in addition to the existing tools, it's the reason is reflected very well by this diagram here, which is in Richard Otis' PhD thesis. And when we do CAFAT modeling, we take the data from the literature of on your calculations, and then compile the data into the form you can use. So then you didn't keep those original data or the literature, or we call it metadata, got lost. And then during the process of CAFAT modeling, you develop a databases. And after that one, you have the database only. Then you lost the history, how the database was developed, and how the data, what the data were used. So at the end, you got a database file, which is actually a very small file, lost a lot of information, very valuable ones. Those information are very, very important. This is because when you have a multi-component database, if you want to change a one component element system, or you want to change binaries, a lot of systems you have to change. And at the moment, any of this commercial code cannot do that, or we don't have the tools to do that. That's why we started to develop a SBA and a PARC in the last 10 years, more than 10 years now. But the new CAFAT is less than 10 years. SBA was a bit older, but the PARC is newer, and with the PARC we redeveloped the SBA by Richard and Brandon. And these tools, you can say it's divided into kind of 3 groups. One is data generation. You can do the first principle calculation, got the data, you can machine learning, and then data processing. So PARC and the SBA is for data processing. And after data processing, you can also do uncertainty quantification. So this is, you think about it, you have the generate data, then you have the CAFAT modeling, then you have the uncertainty quantification. So PARC and SBA enable the uncertainty quantification in terms of the parameters and also the predictions. And they're open source code, so the community can build on those tools for a wide range of properties. And we do have a YouTube channel called the Material Genome Foundation. This is the link. If you search Material Genome Foundation in YouTube, you should be able to find this channel. Okay, so with these tools, what's our goal? Our goal is really create a new data ecosystem. So you can create a lot of data, right? From DFT, experiments, machine learning, and also mechanical property by the finite element method, and of course by experiments. And this data, we call them proto data. They give you the individual data. And they want to use this data to create databases. So with SBA and PARC to create databases. And with these databases, then you can do the material design. You can design the manufacturing and design the service, a lifetime, for example. And then you will generate new data. So we want this new data can get into the proto data system and revise the database, refine the database. And then when the lifetime of the materials comes, then you get a material recycling, they get more data. So we wanted this kind of system can continuously improve itself. Since that one, we want to new materials and continuous service and manufacture and recycle. To really reflect what the ecosystem, we want to reflect, we have a figure here, diagram here to show that how it reflects as the ecosystem. So we want to have data, you have data from the different sources. When you combine this data, when this, we call the ocean of data, and then we can use this data to use aspect or other tools to generate databases, and then for design, produce new data and enrich new, develop new materials, and then continue the cycle, just like how nature works. Of course, many times that you have some data you don't want to share with people, right? So we think that there should be a mechanism, and also do the proprietary data can also integrate with the big data, ocean of data to do that. Okay, so that's my very short introduction for why we develop a PARC and aspect. Again, I want to thank Richard Otis and Brandon Buckland. Richard graduated 2016 from our group. He is the main developer of PARC and he started aspect. Brandon continued to develop aspect. Hopefully he will graduate next year and continue his professional development after that. With that one, I would like to introduce Richard Otis to continue on the PARC.
Thank you, Dr. Liu. So I'm very excited to see so many people back for the second part of the virtual workshop. I hope it's been informative and useful to all of you so far. I did want to pause for a moment and check to see if we had any questions, particularly maybe like higher level questions or vision type questions that might be appropriate to ask Dr. Liu. Do we have any such questions? Well, that's okay. If we do have further questions during